So the question is the following. If this spike is charged by 20% when he starts, so here the point start, he has 20% of the bulk. And he has to reach the end, the exit, meaning this end, before the power runs out. He has to make sure that he has energy to reach the end. How many seconds does need at least need to reach the exit? So what is the minimum number of seconds that are required to arrive to the exit? So he can choose between these options. So on the blue path, he can go slow or fast. On the red path, again, he can go low or fast. But what is important is that we reach the end, meaning that we don't run out of energy on the cells before reaching the end. So let us think about this. This is quite an interesting problem. So let's start. Let's see. If we go from the start, the first part, let's say we go at full speed, then we're going to use here, if we go for all the paths, all three paths, at full speed, we're going to use 10% at each path, right? Meaning that we are not going to reach to the cell because we only have 20%. So we cannot go full speed, that's for sure. What we could do is go one full speed and then two slow speeds. And then we are there at the end of the energy, just at the end. Right? So we can go one at full speed and two at slow speed. So we are at the cell. And then we recharge. And then we have again 20%. So now we have a red one and then another blue one before the cell. So on this red one, if we go at full speed, we're going to use all the 20% that we just received and we're going to stop. So we cannot arrive to the other one. So we cannot go full speed. So we need to go slow speed here. We need to go to slow speed here. And then on the blue one, we can go fast speed. Because on this one, by slow speed, we use 10%. And here on the blue one, we can go fast speed, again 10%. And it's fine because we reached again the cell. And then finally, we have another red one. And then comes the cell again. Meaning that on this red one, we can go by fast full speed because we have 20% for the last cell. And finally, on the last one, we can go, of course, by fast speed because it's just the end. And so this would be one of the most optimal ways to go about it. And what I told you is just a sort of greedy algorithm. I just tried step by step to optimize it. I didn't think about the full solution or trying to see if I do here some more engineering things like I go on slow and get 5%. So this thing, it was not so, let's say, I didn't take too much to see what happened afterwards. I was just looking at the first, how can I optimize the thing until the first step. So by doing this approach, let's see what would be the time by this thing. So by doing two of them in slow motion and one full speed, that would mean we take here 2 times 20 seconds, meaning 40 seconds plus 10 seconds, so 50 seconds for the first step. On the second part, we said that for this one, we have to go slow. So slow meaning another 40 seconds. We are at 90 already. And another one at full speed here, 10 seconds. So this is 100 so far, yes? All right. So here we have another red path, which we can take at full speed, and this takes 20 seconds. So 120. And finally, we can take this last one again at fast speed, more 10 seconds. So 100 seconds. So So I think here we have basically this calculation in this step in the first dimension. So one blue path in fast mode and two in slow mode, and then this calculations here, then the 40, and then we have one red path in slow mode and the blue path in fast mode. So again, this is another 50, and then the red path in fast mode and the last path in